Are we just doing day one again?
Oh, hang on. I'll get to that. So, we're going to construct some inscribed things and circumscribed, but I want to give you a note with some definitions, okay? Because sometimes they just will throw terms out there, never really define what it means, so let's do that now. Let's go to our notes page. It's like right here. Okay. So if we're going to inscribe one figure inside of another one, let me define what that is. Inscribe, okay? Means the figure is drawn inside another figure, okay? Or constructed even. Drawn inside another figure. Okay? And when we do that, all the vertices of the inner figure are on the outside figure, right? So all vertices are on the outer figure. And then it's inscribed. Okay? So maybe we have, just a diagram, a circle, and I'm going to inscribe a quadrilateral. Okay, everybody see that? So we have a quadrilateral inscribed inside a circle. Okay, we say the quadrilateral is inscribed. But the thing on the outside, from this point of view, it's not inscribed, it's what we call circumscribed. Okay? Yeah, I know that every year the morons come out and think they hear a word that it's the same as another one. Whatever. You're gonna be quiet now. So that just means drawn outside another figure. So drawn outside another figure. Like the prefix circum based on circle, right? To circumnavigate the globe means to go all the way around it, right? Yeah. To circumvent the rules means to go around the rules, okay? Circum, right? I think you probably know what the other one means, but that's not what we're talking about, okay? All right, so that's those two terms. Now, a triangle median you need to know. Triangle median, you need to know these terms, because they'll show up on the regions, okay? So it's a segment drawn from a vertex, different than the one we did earlier. Segment drawn from a vertex to the midpoint of the opposite side, okay? Not necessarily perpendicular, okay? So it's a segment drawn from a vertex to the midpoint of the opposite side. Midpoint of the opposite side. Okay? So let's say you had to construct a median in a triangle. You know it goes to the midpoint of one of the sides, so what construction will you do to find that midpoint?
Angle bisector, segment bisector.
Yeah, well, perpendicular bisector, but not drawing it, right? Because that'll help you find the midpoint, and then you just connect the line, right? So probably do midpoint construction. So if we have a triangle like this, right? Let's say that that's the midpoint of this side, right? So this triangle's median would go from a vertex straight to that midpoint, and those are congruent. Okay? Not necessarily perpendicular, okay? That was the thing we did earlier for the altitude. This is just a triangle median. And you could imagine you could draw how many medians in this triangle, or in a triangle? 3, right? And, interestingly enough, they all come together at a single point inside a triangle, okay? It's called the concurrency of the medians, right? They're concurrent. And if you go into like physics or even engineering, right? If you have some thing that you're actually designing, some object, right? And you want to find the exact center of mass where you could balance it on the tip of a pin, that would be that point where the median's coming from. Okay? So stuff can be useful out there. Okay, now here's another really important thing, okay? If you have an inscribed triangle, okay, inscribed inside a circle, you with me so far? And one side of that triangle is the diameter of the circle. So inscribed triangle, one side of it is the diameter of the circle. It is a right triangle. Okay? We got that? Write it down. So this is important to know. So if an inscribed triangle, and inscribed, and you know what that means already, triangle has as one side as a diameter, let's phrase it that way, has one side as a diameter, you know, the circle it's inscribed in. Okay? It is a right triangle. It is a right triangle. Okay, this is important. It's the concept you'll run into in the test a lot of times, okay? So two conditions have to be met, right? First condition is the triangle has to be what? Inscribed. And the second condition is one side must be what? Diameter of the circle. Draw a quick sketch here. Maybe a little sloppy, but. So here's a circle, and let's say that's the diameter, right? Center like that, okay? So inscribed means all the vertices of the triangle lie on the circle, right? So let's say I have a vertex there, there, and there. So everybody can see that inscribed triangle, one side of it is the diameter of that circle, right? So that means then that this is a right angle, 90-degree angle, and that is a right triangle. So maybe you're thinking, well, what happens if this point is over here? Same. Anywhere, same. It's still a right triangle. Got that? So it has to be inscribed, and one side has to be the diameter of the circle. All right? So let's keep that stuff in mind. Let's go back to a couple of these constructions here. Oh, there it is. Okay, so our first one. We're going to construct an inscribed equilateral triangle. You know what inscribed is, right? Now, an equilateral triangle, what is it? Equilateral. All three sides are congruent, okay? So, like we normally do, I want you to look step by step here. Try and follow along. I will say, like this second step here where they draw a complete circle, don't necessarily need the whole circle, right? So, I mean, we could start, you could have it, right? But all we need to do is have these two intersecting points like that. But read through there, right? And I'll come back to it and we'll see how you feel about it. What's the first thing you need to do if it's not there? Huh? What was step one? Yeah, just use your straight edge. Just make sure it goes to the center. Doesn't matter like what diameter. It could be right up, down, angled, whatever. As long as it goes to the center. And like I said, a lot of the problems already have the diameter. Okay? What's the first measurement we take? This radius, right? So we put the compass point, put your compass point right here, right? On one end of your diameter, open it up to where? The center. And then make an arc that just intersects twice. You got it?
You make an arc that intersects twice?
Yeah. There's one over on the other side. Spin the other way. We're on the other side. You forgot the diameter. You gotta have the diameter first. You need that point. You need this point here where the diameter hits to do this accurately. So you gotta have the diameter first. Okay? Hey, so once I had that arc there, all I do is connect the dots with my straight edge. How many think they understand it? Okay. Oh, I thought I was. Oh, I am recording. Okay. All right, so I'll do it with this on the bottom of the page. You guys follow along here, or do it on your own. So down here, let's give it a shot. The first thing I'm going to do is put what in here? A diameter, okay? Does it matter which way my diameter goes? No, as long as it goes through what point? Center. So let me get a diameter in here. And of course, mine's just going to be off. It just has to be, doesn't it? All right, now I've got a workable diameter. So now, I'm going to take my,
I just stabbed myself with this.
that's a shame.
I mean,
Now I'm going to put it in one, see now, Carter, why you need that diameter there? Because you need a point,
Yeah.
right, to locate things. And how far are we opening up, guys? We're just measuring the radius, aren't we? Like that? So I don't need to make that full circle, right? You can if you want, whatever. So now, yeah, get that out of the way. Now I just, quiet. Now I just take my straight edge and connect the dots. There's one. That one.
Yep, I did it right. I just had to make sure.
I'm going to have a construction that looks like this here for inscribed equilateral triangle, okay? If they don't have a diameter in there, you got to draw one in, right? Then you just open up to the radius, get an arc, connect the dots, okay? Okay, so next one. Now this is one that a lot of people mess up, and I don't know why. I don't know why. You mess up in such a way that I give you 0 credit when I see it. But read this over, and I'll talk about what that 0 credit looks like, okay? Constructing what? An inscribed square. So real quick, if they don't have a diameter drawn in, draw it in. Now, they don't show the marks here. This is what bothers me, I think, about this. Like, I should change that at some point. How do they get this? What do they do here to get this other diameter? What construction?
Circle.
False.
Rotation.
Okay, so here's the diameter, and they got this perpendicular line bisecting that diameter. Which construction is it?
Nice.
Whoa! So we have a segment called the diameter, and we have another segment that's perpendicular to it and bisects it. Ha! This part you must do the perpendicular bisector construction of. Right? So that you'll have, you know, your arcs up here and here, and here and here, right? Everybody got me? Hey, right? You have to have those marks. If you do an inscribed square without having shown you did the perpendicular bisector, you get no credit. I kid you not. Then it's not a construction. Then it's just a guess, right?
Oh, I just guessed them.
No, well, that's a 0.
Yeah, yes.
Don't do that again.
I didn't
That's
know.
wrong.
I didn't know. It didn't show us
Fair
the
warning.
diagram. You had to do the
I know. That's what I was saying. I don't like that, right? But that's why I wrote that.
horrible.
And actually, I did it on the wrong one, didn't I? Because they already gave us the. So really, it's on these over here, like, because we already had that one. So now this one then is, you know, and these are sloppy, but right.
You get no credit. You punch those ones.
Yeah, and they have to be actually constructed, not just flung in there. Okay. You need to show that you constructed the perpendicular bisector of that segment, that diameter. Got it? Everybody clear on that? So don't bother even turning it in if you haven't done that when you did a square. And now, do we have 4 points to connect?
Yes.
Connect the dots. Okay? So everybody try it down here. All right, I'm going to do it so you can watch then. I need to put in,
I'm gonna call it happy.
quiet down. I need to put in a diagonal, or a diameter, sorry.
You didn't use a bisector.
No, he doesn't have to for the first one.
Well, first step is to get a diameter in there. Now,
Now he is.
where I have to get the other one, this is where I must show that I did perpendicular bisection. Because any orangutan can draw a line in there with a ruler, right?
No.
Any single one of them. Well, I've seen it many times.
Not one name.
I know a lot of orangutans.
No, not good.
All right, so hey, quiet. So I got to do the perpendicular bisect of this guy, right? So I'm going to open up way past halfway. Now this is where I like to keep my, I don't want to put the whole arcs in because it could get kind of messy, right? And I'll bring it down here to the other side.
Wait, you measure the whole.
No, I just open up significantly past halfway. Perpendicular bisection.
Yeah.
Everybody told you that's what we're going to use a lot. Get up here, intersect, intersect, get that out of the way, straight edge.
I did a good job guessing them.
Yeah.
Lee did a good job getting the zero.
Literally lines up perfectly. So I don't even have to fix it because like, it looks perfect.
You still get a zero.
I know, but like I'm just like I put it if I put side drum roll guys, drum roll.
Okay, hang on. Let me shorten this up because that's going to be like there. You really only need this. Okay, so you should have that. And one more thing left to do. What is it? Connect the dots for your square. Yeah, what's it?
Landon, why didn't you get a side paper?
Figure it out. I got the Ducky Gun in the
You don't want any friends?
I probably did it wrong, but
See, my stupid thing's not like. Yours is going to be better than that. 'Cause you don't have any digital listens on your page, okay?
Actually, it's pretty good.
Okay. One more time. I'm going to say it again. If you do one of these squares and you don't have the perpendicular bisector to the original diameter, it's 0 credit. Without any question. I don't care how close it looks, because making it look close is not construction.
Chocolate milk and applesauce.
So let's be quiet about it. Let's get the lunches quietly, because we're still doing stuff. We'll talk about your lunch after you leave here. Okay, guys. What's the next one? How many sides does a hexagon have?
6.
6. It's regular, so they're all congruent. Now, as you read through this, you'll see that it starts out a lot like your triangle. Put in a diameter. Put in a diameter, and then measure your radius, right? Sketch this arc. Again, you don't need the full circle. But what's different here? So it's almost like an equilateral triangle, but what's different after that step? You just do it again on the other side. Now you have 6 points to connect, right? And again, you don't need the whole circle. You can just kind of, so you don't need all that. You don't really need all that. You just need to clearly show you intersected twice for each of them, right? And be accurate, right? Because you want, with the two arcs come together there at the center, you really don't want it to like overlap and have a gap. So you want to kind of take some care when you're measuring those arcs and making them, okay? So let's give that a try down here. Get my compass. I'm fumbling around with this. What's the first thing I need to put in here? Diameter. Yeah, not bisect. No. Okay. And now I'm going to, like we did with the triangle. Yep, we'll do that thing. There shouldn't be any talking because you're all constructing an inscribed hexagon.
I'm eating.
Well, then do it quietly. Why is there talking? I'm not talking about applesauce, neither should you. All right, so mine's going to be a little off here because of my, you know why. God, Jesus. But we not slurp so much there. That'd be pleasanter. So I get that arc, and now I'm going to come up to the other end of the thing here. Get this other arc, and hopefully, so that's not too bad. See, well, I got a little overlapping gap, right, but it's hard because I had pixels are not lining up right. And now I just take my straight edge,
This doesn't give me enough room.
connect those dots. Sure it does. So how do they look? About like what I have here? You see, it's a lot like the equilateral triangle, except you just put an arc in on the other side, right? That makes sense, right? Because triangle has how many vertices? Triangle.
All three.
3. And the hexagon has how many vertices? So you got to throw another 3 in there, right? Okay? All right, let's see what's after this. Oh, that was it then. Okay, so listen, we construct an equilateral triangle, inscribed, construct an inscribed square. What's the thing that you must do after you draw the first diameter when you're doing a square? The perpendicular bisector to get the other diameter accurately. Don't bother even doing it without doing that, okay? I know half you'll probably do it, and that's whatever, it's 0, okay? And then we did the hexagon, which is a lot like a triangle, but just the other arc. Yes, sir? Oh, hang on, let me do what I'm doing, and then we'll get to your question. So for the problem set. Oh, wait, we got some Regents questions.
Are you kidding?
Oh, I'm not kidding you. We won't get to all of those. Well, let's just get to the.
Let's have a test too.
Let's hit a couple Regents questions here before I give you the problem set.
Do like the first three.
Let's just stop talking.
The problem set from homework.
Just hang on, Howard. Don't panic. I'll make it so it all works out for you, okay? Whatever I decide here in the next few minutes in my superior brain.
I'm trying to get it out.
Okay. So
10 minutes in everything.
read over this Regents question. Should look quite familiar. All right, so I'll do this and see who's following along. They gave us the first one, so I just need to correctly construct the other diameter. And I like to go pretty wide for this one. I like my intersecting marks outside the circle just to keep it neater, but that's not critical. But again, like remember I told you before, sometimes our constructions get a little more complex and it can get messy. So whatever blows your hair back.
Yeah. The wind. Okay, let's have a conversation about.
Let's not do any such thing.
And then I go up like.
And you're doing such thing, but we're not going to do any such thing.
She's Carter.
Hurts, okay.
It does,
So
yeah.
are we supposed to go 1.8?
I can't get any labels after that.
Same way we've always done perpendicular bisectors. Nothing
Why is
different.
mine, I did it right, but it's wrong.
That'd be great.
Well, then you did it wrong.
Anybody want that?
It's wrong for Rucker.
So about like that, then I got Quiet back there. Quiet, I just said quiet and I still heard a voice. There. Like that. Fix that one a little bit. All right, does everyone's looks like that? You see this here? They were clearly constructed with my compass. Right? So sometimes kids won't do these at all, 0. And sometimes they'll just, gosh, I'll just put marks that look like I did it without the compass. That's also a 0. Okay?
How do you know though?
I've been doing this since you were zygotes.
I bet I can.
No.
I bet I can pull your leg with it though.
You know what a zygote is?
No.
It's that moment where the egg and the thing can meet fertilize, right?
Didn't know that.
Oh, since-
Anyway,
Since I was siloed. Or,
since you were real little, or even before. Before, yeah, God, before.
That was a mistake.
How old are you people now?
Yeah, me too.
14?
I'm 43, 16.
Way before.
it's for
Make an extra.
What are you constructing here?
Extra.
I think we just did that. Was that the last one we did?
I didn't. I was reading, so I don't know how to do that.
What's the first thing you're going to put in here? There you go. So let's all get to it.
First, I can go with a straight line, correct?
All line.
What did I do wrong this time?
So I need a diameter. I'm going to put that in there.
I know that's like kind of bisector. Well, I wasn't doing hexagons. So.
Well, you probably should do hexagons. I think that's what they're.
No, but I was even and I have a very one-track mind.
Okay, I got you.
I'm
So
just gonna watch him.
I'm going to measure a radius here. About there. And I'm going to,
How many foot?
like that. I'm going to do the same thing because that would be enough for the equilateral triangle, right? Now we need 6 vertices, so.
I want to do it for full circle. Yeah.
A first circle.
He's over here, yeah. He's over here yelling at me. God bless your heart.
Okay.
Like a man.
So now I have 6 points to connect. They're all the same length, and I'm just going to connect them.
Wait, I don't have to do full circle.
You can, but you don't. I don't. Why is there talking back there? Why constantly? It's like right from that same area. I wonder who that is.
It's Lando.
What?
He talks a lot. Nick.
All right.
Thanks so much.
Now, were there any other instructions on this? Did they tell you to label it any kind of way? No, they didn't. Sometimes they will, and you have to pay attention to that. Okay? Are we good with that? Anybody have any issue with this? All right. What's next?
The only draw. I have an issue actually. I don't know what I'm doing.
Okay. What's this one?
You gotta make a circle.
Nope. Yep. Your other directions. Yes, median. I defined what that is, right? On your notes page?
Yeah, sure.
So it's the triangle median. Goes from the one of the vertices to where?
Yeah.
Well, that'd be a side, actually. Go from one vertex to the other, that's a side. To the midpoint of the opposite side. How do you find the midpoint of that side? Which construction? But you just don't draw it all in, right? Yeah. Yeah.
You can
Okay.
also do it like you would do an angle.
No, because this is median. We're not doing.
Upside
You know what, sir? Okay? Now, you better note, though, this is important. Let's say you do a correct median construction, but from the wrong vertex to the wrong side. What did they say? It's going to AC. So what vertex will it be coming from?
I
B.
have that wrong.
So it'll be here to the midpoint.
Oh, okay.
You got to be careful. A lot of kids just do it there or whatever. What? I don't know.
So,
Did they give you what?
so it's not all the way through.
Yeah. Everybody here, Lily? Lily knows that we need a diameter before we start the inscribed equilateral triangle. Did they give us that? Well, they didn't. So what do we have to do with this radius?
Right the other
Just
half.
extend it so it's a diameter. That's it. And then you just do your thing. Okay? Then you just do your thing.
a lot of fun with it.
Right.
Okay, just extend it down and then you can do your compass, right? Radius.
Why don't you just take a checkout list on the board of people who take a compass home to?
You don't think I have enough to do? I gotta keep track of all that now? Ah,
No, bring one back.
I think we should
and
just not do homework except for compasses.
we'll be fine, don't worry about it.
forth.
I mean, I have considered that, but then I just decided no. Easier.
Hey! Oh! That was so cool.
Quiet. No talking. Kid.
Okay, I'm sorry. No, I've just sitting here for 3 hours.
Yeah, me too.
I know, but
So, you know,
I'm 14 and have a 10th spare of getting
I'm 50. Things hurt. So it's worse for me.
You should be doing house calls.
I don't think so. I feel like it. All right, so now we just connect the dots, right? We're good with that?
Wait, a triangle? Hold up.
I wonder how we knew it was supposed to be a triangle.
It says an equilateral triangle.
Is that how we knew it said it, the directions?
Yeah.
Okay.
Yeah.
All right. It's a good way to know things, right? We just learned that.
And then you're supposed to.
Okay. What's the next one? Yeah, another hexagon, but we have to do something with it. And then there's a follow-up question. So I think you guys know how to do a hexagon. So I'm gonna just start cranking through this. Okay. So a little angle there. Compass.
Any size or no?
Measurement of this and then
So there's that part of the hexagon. Okay. Shh. And that part. So I think hopefully we're getting this part now. Now we connect them all up here. Using that.
it's okay that I only do like where they intersect. I don't do even half the
Oh, yeah, that's fine. But you gotta be careful with that because sometimes kids will get so short with them, it's not really clear like where it came from. So leave some of the arc. So it's like when we put our compasses on to compare it, we need it, right? That's fine. Because I think they did that in the book, right? That's fine. So if you have that, then what is, you gotta read the directions. What else do we need to do?
It doesn't matter which way you label it.
It doesn't as long as all the labels are in order, in either direction, but they ought to be in order around it, okay? You can't just randomly put them, right? Everybody get that? So I don't know, maybe I'll start here. Call that A. And then I think I'll go this way, B, right? Just as long as B follows A, C follows, right? Doesn't matter. Wait, that's E. Okay? How many have it set up like this? Good. Got it labeled? Maybe you went maybe you put your A here and you did A, B, C, D, yeah, this still doesn't matter, okay? All right, let's take a look at the follow-up question. What's that say? Oh, by the way, a chord. They use the term chord. Do you know what a chord is?
Yeah, I go for it.
That's an accord, which is the name of a car or an agreement.
It's like just the line. Simple.
So a chord is just a segment whose endpoints are on the circle. Right. So real quick,
Oh,
like a chord
Guitar.
is like that, or like that. Those are chords. And by the way, the diameter is a chord that goes to the center. Okay. Chord just has the endpoints on the circle. So I'll read that over. So maybe those chords that they're indicating, you should probably sketch in there, or use your straight edge and put them in there. So chord FB and FC, we'll still do that. And yours would be kind of differently situated depending on where you started your labeling. That's okay. I'll do it with different colors so we can highlight it. Maybe that's what
Makes it shine green.
So FB, they said, right? And what was the other one? FC?
Triangle.
Okay.
It is a rectangle. What's it?
Oh, okay, that's what we're getting at. So, again, what kind, so they asked, what triangle would FBC be, the one we just sketched in there?
Right side.
Okay,
What if it's like?
and then they said what? Remember, there's two conditions that have to be met. It meets both of them. What were the two conditions? First of all, that triangle is what? No, the reason.
All the angles.
Inscribed is the first condition, and also what? Go back in your notes page.
Add up to 180.
No.
All triangles.
So we can say that triangle FBC is what? Is a right triangle. But then they said explain. And there's two parts to it. Look back on your notes page. What are the two parts? Why? First of all, it's inscribed,
And the one side is the diameter.
and one side is the diameter. So you need both of those in your explanation, right? Because that's what's required. So, is a right triangle. I've maybe put comma, because it is inscribed. That's important to have there. And what? And one side is a diameter. Okay? It's important to have both of these reasons because it is inscribed and one side is a diameter. So if you see this on your test and you only have one or the other, then you lose points, okay? So if you just say one side is a diameter, you lose points. Why? Because you didn't say what? It's inscribed, okay? Was there another question after this? Oh, we finished all the reading. That's perfect timing, isn't it? Okay.
Yep.
So,